All right, so we want to prove these theorems. We've got a postulate, the corresponding angle postulate. Okay, we can use that, and we can use anything else that we've used already. Anything else that we've proved or defined or anything like that, we can use all that stuff. All right. And in the last chapter, we did some paragraph proofs where we just kind of lifted things out. An important thing to understand about proofs is you always got to have a reason. Okay, got to have a reason for everything you say. Okay, and we got to have enough evidence that makes our conclusion bulletproof. All right. So we're going to have a given and a prove statement. Okay, what we want to start with and what we're going to get to. So here we're going to say given, we got M, line M is parallel to N. Okay, so you can sketch this little drawing as well. So M and N are parallel. We can show that with these arrows there. And we've got a transversal cutting across it. And let's get some numbers here. We'll need this, let's say 1, 2, and 3. Okay. All right. So this is what will be given to us on a problem like this, and we want to prove that angle 3 is congruent to angle 2, because that's what the alternate interior angle theorem says. Right now it's just a conjecture. We just think that's true. It sounds good. We haven't proven it yet. Okay. So that's what we're given. That's our information here, and that's where we're trying to go with our proof. And so we're going to do a 2-column proof. And most of our proofs that we'll write out this year will probably use a 2-column proof. Okay? Paragraph proof is nice, but it takes a lot of writing. And so this just kind of simplifies it a little bit. All right? And so it goes like this. Okay, we'll make 2 columns, imagine that. And we're going to have, in the left-hand side, we're going to have our statements. And over here, we're going to have reasons. You've got to have a reason for everything you say. And proof. Okay? Here's our 2 columns. So, let's jump into it here, see what we can do. Give me a statement that you know is true. What's that? Okay, good. Angles 1 and 3 are vertical angles. Let's just start brainstorming before we jump into it. We know angles 1 and 3 are vertical angles. What does that mean about? They're congruent. Okay. Good, very good. What else do you know? Yes. Angles 1 and 2 are corresponding. Very good. What do you know about them? They're congruent also. Very nice. Lines M and N are parallel. Very good. How do you know that? That's good. Don't avoid the simple stuff. It's given. You got to state that, though. Just because it's given doesn't mean we can use it. You can only use stuff that's written down here. Yes. Good. By the definition, we have to know that those are alternate interior angles, right? Okay. Very good. Okay. And Avery, you got something else?
By transitive property.
Oh, okay. Well, yeah.
2 and 3 would be congruent because 2 and 1 are congruent and 1 and 3 are congruent.
Okay, good. So there's kind of the last piece to tie it all together. So we know that 1 and 2 are congruent because they're corresponding, right? We know 1 and 3 are congruent because they're vertical. And so 3 and 2 have to be congruent by transitive. Do you see that general picture now? Okay, it's very important before you start writing out a proof to think it through. So think it through, because sometimes you start writing things down and you get all lost in all the writing. And you're like, I don't know where to go, okay? And one nice thing about proofs is there's lots of different ways you can go. There's not just one route, usually. Okay? All right, well, let's start that out. A good place to start is with the given. Because we can't use any of that stuff until we say the given, that M is parallel to N. And a reason, well, that's just given. Okay? In a paragraph proof, we would maybe write out, we know that M is parallel to N because it is given, period. Okay? That's a paragraph proof. Well, this kind of proof, we just, here's our statement, here's our reason. Okay, and that's that. All right? So, all right. So let's say one more thing here. Let's go with maybe what Zach said there. And angle 1 is congruent to angle 3. And why is that? I have a reason. You said vertical angles. Okay? So that is our vertical angle theorem. Okay? Now, you can say this. You can state the name of the theorem. Last chapter we named this vertical angle theorem. We said that vertical angles are congruent. Or if you don't know the name or you're not sure what to write, just write it out. Vertical angles are congruent. Okay. So if it's a short little theorem, just write out what it says. And it says vertical angles are congruent. Okay, that's fine. Question? Or we got something else?
In the homework, I had like things where it was like like I was getting like postulates and like theorems and like definition wrong.
Okay, so some of that stuff is kind of is a little flexible. All right. If you said postulate when it should have been definition, or you said definition when it should have said the postulate, we'll be a little flexible there. But it's important to understand a definition is just something we say. This is what it is. These are alternate interior angles. Okay, that's what we are. We're defining them to be alternate interior angles. These are supplementary. They add up to 180. That's just the definition of 180. I'm sorry, supplementary. They add up to 180. Okay, so well, as we move on, we'll start to get the hang of what's a postulate, what's a definition, and so on and so forth. Okay, but we'll be a little flexible for now on that. Okay, so let's go to one more thing. Let's see, I think it came from over here. What type of angles are angle 1 and 2? They're corresponding. So what's true about them? Okay, now what is that? That's the corresponding angle. We can use that abbreviation we talked about. The corresponding angle. Is that a definition, a theorem, a postulate? That's a postulate, okay? And again, if you say theorem instead of postulate, we're not going to freak out, okay? It's a postulate. It's good to know that we never proved this. We just accepted it, okay? And we're almost there. Now, if 1 is congruent to 3 and 1 is congruent to 2, what do we know about 3 and 2? They're congruent. Why?
Isn't that also like syllogism?
Yeah, that's a good point. This is like syllogism, but syllogism deals with if-then statements. So it's a good that you see that connection. Syllogism is logic, and this is a congruence. So we have a name for it. What's that name? No. You said it a second ago, Avery. Intransitive property. Okay. So angle 3 is congruent to angle 2, and that is the transitive property. And we're done. Okay? Transitive property, again, the 3 little dots means therefore. This is our conclusion. We're done. Dun, 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 dun. Okay? Grand finale. There it is, 4 steps. Pretty straightforward, right? Okay? So we're taking things that we know are true, the vertical angle theorem, the corresponding angle postulate, the given information, tying them together and saying, well, this has to be true. 3 is congruent to 2. So the nice thing about this is you never have to do this again. Okay? We have now proven it. From now on, we can say, hey, if we have alternate interior angles, they're congruent. Period. We never have to go through these 4 steps again. So all we got to say is, I know these are alternate interior angles, so they have to be congruent because I've already told you they are. Does that make sense? And that's the process of geometry. That's the process of building a mathematical structure. We know this is true, so this has to be true, so this has to be true, and I'll prove it to you, I'll prove it to you, I'll prove it to you, and then we just use it because we already know it works. Okay? So, questions on that? Yeah.
Do you know when roughly the last theorem was created?
Probably yesterday. Okay? Theorems are a way that mathematicians come up with new information. We know that this has to be true. Now, it might be a theorem about something that you and I might not ever care about. It might be a theorem about how certain types of hyperbolic numbers relate to certain types of fields of numbers and things that we have no idea about, okay? And that's a theorem, though. And some mathematician probably came up with a theorem yesterday about something like that, okay? And so that's how we say, I'm going to show you this is true, and I'm never going to have to say it again because I'm going to prove it. I'm going to write it down. I might publish it in a journal so everyone can see that it's always going to be true. And now it's a theorem. Make sense? Okay, the last thing is this, and then I'll turn it over to you. Last thing is this. Now, that's nice, but this is only true if the corresponding angle postulate is true, right? What if somebody comes around and says, wait a minute, the corresponding angle postulate is false? Then what happens to this theorem?
Boom.
It's gone. It goes out the window. Okay. Now, we're pretty comfortable that that's just a true statement, okay, and all this other stuff. But anyways, okay. Let's leave it at that. Go ahead and let's do this now, all right? So, we'll leave that one there.